Hi there. We are going to be looking today at solving equations and inequations using the absolute value function or the modulus function. And in order to be successful with this, we need a few understandings. One of them is that it is difficult to work with the absolute value because it is a piecewise function. So when solving equations, it's quite challenging. Therefore, in some particular cases, we can get rid of the absolute value from the equation by acknowledging that absolute value of x squared is the same as x squared. So remember, the absolute value of x is the distance from the origin, or is x if x is positive, and negative x if x is negative. Therefore, if we square it, we get x squared for x positive and negative x squared for x negative. So in both cases, it's x squared. This technique of squaring helps me getting rid of absolute value, but I'm going to end up from linear expressions that you find here to quadratic. However, it's a good strategy at times. Also, when solving equations, we need to acknowledge that if a is b, then of course a squared is equal to b squared. So we can square both sides. But if a squared is the same as b squared, it doesn't mean that a equals b necessarily, because we can also have a equals negative b. For example, 2 squared is the same as negative 2 squared. So a is 2, b is negative 2. But a is not equal b in this case. Therefore, when we square both sides, we introduce some new solutions. For example, if we start with the equation x minus 2 equals 3, then it has a single solution, x equals 5. If we square both sides, then if we solve this equation, we are going to get x is 5 or x is negative 1. Try to see. Therefore, if I square both sides, I need to go back and check the solutions against the initial equation, that if that's my starting equation. So I'll go at the end and say check. X equals 5. 5 minus 2 equals 3, correct, so 5 is the solution. X equals negative 1. Negative 1 minus 2 is not 3. So this one is not applicable. So the only solution is x equals 5. The last thing we need to acknowledge, because that's where from misconceptions come as well. So we have A, B, and C. The last thing we need to acknowledge is that if A is smaller than B, it doesn't mean that A squared is smaller than B squared. For example, minus 2 is smaller than 1. If I square both sides, I get 4 and 1, where 4 is bigger than 1. See? But minus 2 is smaller than 3. If I square, I get 4 and 9. So the relationship, the inequalities sense keeps. It's a problem when I square sides that have different sign. That's a problem, because if we look at negative 1, negative 2, and compare it to 1, if I square negative 2, then negative becomes positive, but this distance is 4. It's further from the origin than this one. That's why 4 is bigger than 1. That's why when I square, this side becomes bigger. Whereas if I compare negative 2 with 3, the sense of the inequality keeps, because the distance squared becomes 4. This is 9, so 3 is further from the origin. So I can't easily square both sides of an inequality. See here, we square both sides of an equation of an equality, but then we get a few solutions that we can go back and check. It's the same problem, but here there are many, many solutions to inequality, so I can't go and check all of them. That's why I can't use this method. However, if both sides are positive, if a is smaller than b and both sides are positive, then a squared smaller than b squared, as you see in this example here. Oh no, I didn't have such an example. So if both a and b are positive, but a is here and b is here, of course when you square, a squared is smaller than b squared. Also, if a is smaller than b, but a and b are negative, then a squared is bigger than b squared. And that's an example here, a and b. So both are negative. When we square them, they become positive, and a squared is further from the origin than b squared. Lastly, if a is smaller than b, but they have different signs, of course, we can't have b negative and a positive, because then a cannot be smaller than b. So that would only be the case when a is negative and b is positive. Then I cannot square both sides, because I can end up with any of these two cases there. So I don't know what am I ending up with. When we work with inequalities with absolute value, very often we know that both sides are positive, because absolute value of x is always positive. Remember the graph from last time. That's a graph of y equals absolute value of x, and it is positive for any x. So we can square if both sides we know that they are positive. Let's take a few examples. There are a few ways to solve this equation. How I'd solve it, I'll square both sides, because I know that when squaring the left-hand side, I get rid of the absolute value. So square both sides. And I get 3x minus 2 squared equals 1. When solving this equation, I get either, you can open the bracket and solve it as a quadratic, or 3x minus 2 is 1, or 3x minus 2 is negative 1. So from here I get x equals 1, from here I get x equals 1 over 3. And then I go and check solutions. So x equals 1. Absolute value of 3 times 1 minus 2 is 1, correct, so that's a good solution. X equals 1 over 3. Absolute value of 3 times 1 over 3 minus 2 is absolute value of negative 1, which is 1. So it's a solution as well. Therefore, my solution set is 1 over 3 or 1. Some people prefer to solve this equation using graphs. So if I am to graph y equals absolute value of 3x minus 2, I first graph y equals 3x minus 2. And that looks something like this. Therefore, the absolute value function is here. And then I will look where absolute value of 3x minus 2 is 1. So that's why it goes 1. And I see two solutions. One is somewhere here, probably it's not to scale, because see, I must get them both positive. So now I know the answer, right? So 1 should be somewhere here. Y equals 1. Now, solving the equation using the graphical method involves a bit of an analysis. Involves looking that this branch is y equals 3x minus 2, and the second branch is y equals negative 3x minus 2. So we are going to find solution, let's call it solution 1, from the branch minus 3x minus 2. intersecting the line y equals 1. So minus 3x plus 2 equals 1. Therefore, x equals 1 over 3. And we are going to find solution 2 from the branch 3x minus 2 equals 1. So x equals 1. Now you choose your method. These are the most common type of equations that we are going to meet, though of course with absolute value you can create many others, but they will be more difficult than this one. And this one will be based as well on squaring both sides. So if left hand side equals right hand side, then when we square both sides, they will be equal again. So squaring absolute value of 3x minus 2 and squaring 1 minus x means, as we saw before, that we get rid of the absolute value. Therefore, we'll manipulate quadratic equations. When solving the quadratic equation, that's what I got. So remember, at the end, we check the solutions. Whenever we square both sides, we check solutions because we might introduce new solutions. So check x equals 3 over 4. 3 times 3 over 4 minus 2. And the left-hand side is 9 over 4 minus 2. 1 over 4. Negative 1 over 4. And the right-hand side is 1 over 4, correct? So x equals 3 over 4 is a solution. Check x equals 1 over 2. 3 over 2 minus 2 is 1 over 2, equals absolute 1 over 2, correct? So both are solutions. And at the end, I write my conclusion. So 1 over 2, 3 over 4 are the two solutions. Of course, you can look at this equation graphically, graphing the left-hand side, graphing the right-hand side, see where they intercept, but that would require more analysis of the graph, and it's a longer solution. How do we solve inequations? Remember we said because both sides are positive, being absolute value, we can square both sides and keep the same sense of the inequality. So this will mean that x minus 1 squared is smaller than 2x plus 3 squared. And then I operate with quadratic inequalities. Remember, you'll end up with a quadratic inequality, and generally you end up with an interval. To solve a quadratic inequality, I'm thinking of the graph. One solution is negative 4, another one is negative 2 over 3. I'm looking for positive values, so positive values are here and here. So this is a solution set for your inequality. Of course, I can't check solutions, there are infinitely many, but I do not need to because I know that both sides are positive and I am allowed to square both sides. We are not going to fully solve this inequality, but as you can imagine, pause and try it yourself. I again know that both sides are positive, so I can square both sides and I get 4 bracket x minus 3 squared smaller than 5 minus 2x squared, and then I solve this inequality. How about if I have minus absolute value of 1 minus x smaller than minus absolute value of 2 minus 3x, for example? Then I know that both sides are negative. And either I square them and I change the sense, look at our first slide, or I add them on the other side and I change this inequation into absolute value of 2 minus 3x bigger than smaller than absolute value of 1 minus x. And then I square both sides. As you saw, the previous questions were very carefully chosen, and they generally involve squaring both sides without any variations. However, at times you might be asked a bit of a different question, like for example this one. And indeed, both sides are positive, but if I square them as they are, I don't really get rid of the square root because squaring both sides means that I square this. And then when I open the bracket, I get x minus 1 squared plus 2 times 2, absolute value of x minus 1 plus 4. So you don't get rid of the square root. However, as you can see in this case, I can change it into absolute value of x minus 1 smaller than 3 if I subtract 2 from both sides. And then I can square. And so on. These questions can get very, very tricky over time, but that's a first step with the most simple questions. Here we go with another very important type of inequations. 2x plus 5 smaller than, for example, absolute value of x plus 1. Now, we can't square both sides of this equation because whereas I know that this one is positive, I'm not very sure about 2x plus 5. It can be either negative for some values of x or positive for other values of x. These types of inequations lie under a bigger umbrella of equations of the type absolute value of f of x, let's say, a function, whatever it's inside, is smaller than a number a. And absolute value of f of x is bigger than a number a. And in fact, a can be an expression as well, not only a number. So let's look at the first, and as you see, the second one is the complementary of it. So if we know that f of x, absolute value of f of x is smaller than a, think of a, of course, a needs to be positive, a positive number or positive value, right? Because the left-hand side is positive. So think that a is somewhere here. And you want the distance from f of x to the origin to be smaller than a. So if you want this distance to be smaller than a, then f of x needs to be somewhere here. But it can also be here. So the distance from f of x to the origin is smaller than a. Therefore, this equation is the same as writing that f of x is between negative a and a. Of course, when the inequation is less or equal, this becomes less or equal. Similarly, in the second case, if here is a and here is negative a, you want the distance from f of x to the origin to be bigger than a. So f of x can be either here or here. Therefore, this inequation is equivalent with f of x bigger than a or f of x smaller than negative a. So I can't write them both together as I wrote them in the first case up there. That's a thing to take with you. You are going to use it in statistics as well and in many other areas. So now I'm going back to this equation. I can look at it if I want to start with the absolute value as absolute value of x minus 1 is bigger than 2x plus 5. And see, I'm in the second case. Therefore, this is the same as x plus 1 bigger than 2x plus 5 or x plus 1 smaller than minus 2x plus 5, leading to two inequations. First one will be x plus 4 smaller than 0, so x smaller than negative 4, or 3x plus 6 smaller than 0, so x smaller than negative 2. So the solution for this inequality is x smaller than negative 4 or x smaller than negative 2. Or means either one or the other. Therefore, I can write them both in one, x smaller than negative 2, as the first one is included in the second one. I could have solved this equation graphically, and I'm going to show on the next slide the graphs. As you can see from the graph, and it's clear that this is y equals to x plus 5, and that's y equals absolute value of x plus 1. You want the blue one to be below the red one. So the blue one is below the red one here, meaning that x is from -2 down to minus infinity. And see, with linear expressions, if you are fluent with drawing the graph, solving inequations, it's easier with linear expressions. Let me change a bit the question, and let's look at 2x plus 5. Let's look at 0.5 x plus 3 smaller than absolute value of x plus 1. And as you can see, I chose 0.5 to change the slope of this line and making it a bit closer to the horizontal so that it will intersect twice the second function. And this is how the graph looks like. See, you want again the blue function to be below the red function. So if you want the blue functions to be below the R function, point A has coordinates minus 2.67, so x here is minus 2.67, and the x coordinate of the point B is 4. So your solution to this will be x smaller than minus 2.67 or x bigger than 4, because your solution is either here or here. However, if you want to solve the equation, the inequation, 0.5x plus 3 is bigger than absolute value of x plus 1, you want the blue one to be above the red one, and you can express it in one single expression, one single double inequality, because in this case your x is going to be here. So your x is between, so see, x is between this point and this point. It's between minus 2.67 and 4. And that's, let's say, A, and that's B. And see how they are different. So using inequalities with graphs, it's easier. If I would be to use inequalities with expressions and continue as on one of my previous pages, in this second case B, I would write absolute value of x plus 1 smaller than 0.5 x plus 3, which is the same as x plus 1 being between 0.5 x plus 3 and minus 0.5 x plus 3. And then I would solve a double inequality. A big point to be taken about inequalities is a type of inequality that we meet very often. Absolute value of x smaller than a. And this is the same as minus a less f of x less a. Related to it, absolute value of f of x bigger than a is equivalent to f of x smaller than minus a or f of x bigger than a. So these are two types of inequalities that we meet quite often.